Hello students, today we are in lecture number 44 of chapter 3 current electricity section. I am S Pandey. Student, in last class we have completed with the potentiometer. We have studied one application of potentiometer. It was to find EMF of a cell. My dear student, the one question we have discussed that is very important, how to find EMF if driving cell having any resistance. One more question, my dear student. Suppose if this is the question, you are having to find the EMF of one cell or to compare the EMF of two cells using the potentiometer, then how you will compare the EMF. And the third one, how you will find internal resistance of a cell using potentiometer. So the last two questions we will do tomorrow. Okay, so first here we go with the comparison of EMF. Of EMF of two cell using potentiometer. Okay, using potentiometer. My dear student, we have studied about the potentiometer. It is a device which can be used in different way, but the very important thing regarding the potentiometer, if I draw a very simple circuit of potentiometer like this one, this is the potentiometer wire of length L, this is the driving shell, this is the battery connected with galvanometer, jockey, and this gives the deflection. All right, this is the E and O. Remember, my dear student, this potentiometer is used to measure the EMF, and it measures EMF up to more correct value than the voltmeter. You know very well, voltmeter can be also used to measure the EMF of a cell. But the question, why potentiometer prefer to measure the potential of a cell than the voltmeter? What should be the answer, my dear students? Remember, if you are having a voltmeter, suppose this is a voltmeter, okay, this is a number of division over the voltmeter, and the two terminal of this voltmeter you use to connect with the cell. How this voltmeter will work, how this will give you the reading. If it is the voltmeter, this is the pointer, how this pointer start moving. Actually, this voltmeter takes current from the cell, and this voltmeters have some resistance. Suppose its resistance R, then what will be the net voltage across its two terminal? So the answer will be, the net voltage will be, this will measure that the not exact value of V, but the voltage which has been dropped over this one. It is using for itself some potential from the cell only. Okay, this voltmeter has no any input device to work. That's why it never gives the correct value. If it is of 1.5 volt, then this particular voltmeter will use some voltage, and that's why it will give you little less reading. Okay, it never gives the correct observation. But in case of this potentiometer, we know very well this potentiometer does not require any current for its working. It has a driving cell, this V, and this driving cell actually used to flow the current for the purpose of this potentiometer, for working of this potentiometer. And you know very well, this current drawn by the battery never goes to this circuit. In this circuit, current must be constant. Actually, this is the principle of potentiometer. Okay, so this is the very important question. If someone asks to you, which will you prefer to measure the potential of a cell, so you have to say potentiometer. Why? Potentiometer will give the accurate value of the actual value of cell, because it does not require any current, any voltage from the cell. Okay, now we'll move for the comparison. Actually, this was the question, it was coming in my mind, so I thought to explain. Okay, now comparison of EMF. This is the very simple. Remember, I will not draw here the very simple circuit, but the circuit that has been mentioned in your book that you have to use in your examination. This is also not very difficult, my dear student, because we know that the length of the potentiometer can be increased to increase the sensitivity. We have discussed in very detail in last lecture. So we can increase the length. So to increase the length, remember, we are just turning the wires. This is the 4-wire potentiometer. Here, metal strip of very low resistance I am connecting so that all the wires are in series. Now you are having 2 points here. This is P and this point is Q. Okay, now from P I am connecting here the batteries, the 2 cell, for which we have to compare the EMF. Here the E1 and E2. I hope you are able to see clearly. Okay, E1 and E2. This is the two-way key, a key in which directly you can draw the diagram using the galvanometer. You don't need very hard name to show the high resistance also. This is the point 1, 2, and this is the point 3. Okay, now from this point, look at here, we are connecting a driving cell over here. I will suggest you to draw the diagram, then after I can erase this one as per my need. This is the ammeter which can show the current in the circuit. This is the rheostat. Now the circuit is complete. This is the rheostat, ammeter. This is the driving cell. V, the 2 secondary cell, and P to Q is the length of the potentiometer. Okay, my dear student, what we have to you have to perform. The question will be asked in board in such a way: using potentiometer, derive an expression for the comparison of EMF of 2 cell. Okay, this will be your question in 3 marks, and then after there will be if it is coming in 5 marks, then there will be a numerical question. Okay, my dear student, so we are going to compare the EMF. Here, the first thing we know very well, to do the experiment, because this is the part of the experiment also you have to do. The first thing that should be in our mind, the EMF E1 and E2, it should be greater than, it should be less than the potential drop across the length of the wire, that is the driving cell. Okay, this is the driving cell. The potential of driving cell should be greater. All right, student, you must see the experiment which is based on potentiometer on YouTube. I also prefer to see the YouTube experiment of meter bridge. Okay, this is the part of your experiment. Now this is the entire circuit. Current start moving from here. Now when we tap 1 with 2, okay, when 1 connect with 2, connect with 2. Suppose balance length is x1. Balance length is x1 or L1. Alright. What will happen? If one connect with 2, you can see clearly this E2 is out of the circuit, and as the balance length will obtain, what will happen? We will have E1 directly proportional to L1, or E1 is equals to phi L1. Equation 1. Now we will remove the key, this 2, and now we will connect with 3. Now 2 connect with 3. All right, it is connect with 3, and balance length found to be L2. Suppose it is balance length, now it is L2. What will happen? E2, you can see E1 is out of the circuit. Now in circuit we are having a cell E2 directly proportional to L2, or E2 is equals to phi L2. Okay, this is the equation 2. Now it is very simple. You have to compare. Now dividing equation 1 and 2, 1, and this equation 2, you can compare. This is E1 by E2 is equals to L1 by L2, and this is our required result. Very simple. Remember students, you are starting this particular derivation, you must have to mention, and you have to start from the principle. Otherwise the principal will ask in question it will be written, explain the principle of potentiometer, but you have to start this experiment to write as answer first principle. Remember all the things I have told you in last lecture: principle, then method, then construction or circuit diagram. Okay, you will write the construction, and after construction you have to you have to write the legend, that is A ammeter, RH it is the rheostat, V is the driving cell, E1 E2 the 2 cells, G the galvanometer, etc. Okay, and then you have to write the theory. If it is coming in 5 marks, then you have to write in complete. Okay, theory. In theory, what we'll write? Try to remember. V equals to IR we have written. Do you remember? R equals to rho L by A. Then finally we got that V directly proportional to L, and all time we are using this V directly proportional to L relation, you can see, okay, from here. So this will be the entire answers. Now we'll move for the next application. Okay, I hope this is very simple and you don't have any confusion. Now the second one will be also the very simple one. Here what we got result, my dear student, we got the result while comparison of 2 cell, EMF of 2 cell, we have the result E1 by E2 equals to 1 by R2. If you are having the 2 balance length and the EMF of any one cell, then you can find out the EMF of 2 cell. Okay, now the second one, this one is the very important, and the many students get confused while derivation of this one. What we have to do, we have to find internal, the third application, to find internal resistance of a cell using potentiometer. In short, I'm writing in your notes, you will write in complete word. Okay, there is a very slight change in the arrangement of this potentiometer while finding the internal resistance. Okay, so look at here carefully, then you will be able to draw the diagram. This is not very difficult. the 4-wire potentiometer we are having. This is the potentiometer wire. What we have to do? We have to connect with the metal strip. Now all are in series. This is the point P, this is the point Q. Now this is the cell of internal resistance R, for which we have to do the experiment. This is the galvanometer, and now this is the jockey. Alright, this is the jockey J. Now driving shell. Remember, my dear student, while I am drawing here the driving shell, you can see very clearly at the point P, all the positives are at the point P. Here to find the internal resistance. Also, in previous derivation, we have drawn all the points P at the same point. Why? We have discussed in very detail in last lecture. This is the emitter, rheostat, alright. Now the point P, driving shell, V, this is the EMF, E, internal resistance R. Now we have another branch over here, and this is a resistance with a key. Okay, this is the K, key, and I'm writing here S inside the box. This S is nothing but the shunt. S is shunt. What is shunt? Very low resistance. Very low resistance. This is called shunt. Very low in comparison to the resistance of the entire network. Okay, so this is a very low resistance we use, not very tough. Now this is the rheostat, what we have to do, and this is the potentiometer wire. We have to start the experiment. So first we will just tap this key open so that this shunt is out of the circuit. Okay, this shunt is out of the circuit, so that current is not flowing through this shunt. When this key will open, this will be considered in open circuit and current will not flow through this shunt. Okay, am I clear to everyone? Yes. Now we'll start the experiment. All the things will be also here, like principle, theory, method, okay, everything, and the structure diagram, whatever you want to explain. Now the first we start when key is open. When K is open, suppose balance length found to be L1. All right, balance length is L1. What we will write? This E here, when IZ will be 0, you can see the potential, since current will not flow from here, so the total length, this is the L1, and this total length will give you E directly proportional to L1, or E is equals to phi L1, equation 1. Okay, yes, I don't think there will be any doubt. Now this key will be closed when K is closed. Here I don't have sufficient space, that's why I am writing over here. You have to write in your notes properly. When K is closed, what will happen? When K is closed, now the current will start flowing. Remember, here the current will be 0, here the current will be 0, but in IZ will be 0, but there will be current in this branch, na? Here no current will be 0. Remember, there will be some current now, and balance length will be changed. Remember, now you have to shift this jockey somewhere else. Now the balance length will be changed. Suppose, and balance length found to be L2. Alright, balance length found to be L2. Then what you will write? When, look at here carefully, when this key will be closed and current start flowing, remember the potential across the length, across this length L2 will not directly proportional to E, because now here the potential between these 2 points, not E, it is E minus this potential drop across this internal resistance. Suppose this is the point A and this is the point B, so the potential will be now VAB, okay, and this potential VAB directly proportional to L2. It means you can write, I'm using the black pen, you can write VAB is equals to phi L2. This is the equation 2, my dear student. Got it? Now come to this closed loop. Now in closed loop, look at carefully. Could you find the current? Yes, the current is I equals to, what is the total EMF of this loop? It is E divided by the total resistance of this loop, it is S plus R. Alright, what will be the potential across these two terminal? VAB you can calculate. Here the current is how much? I, the same I that we have calculated. Okay, so this branch and this branch are in parallel, so the potential of VAB can be calculated from here as well here. So the VAB can be written as what? I times S. Am I clear? Yes. Now VAB can be written as I, it is E by S plus R times S. Okay, look at here carefully, my dear student. Now from here we are going to find a relation that we will compare with 1 and 2. Can we write here VAB divided by E is equals to S by S plus R? Suppose this is equation A, and by dividing equation 2 by 1, we will have again the same VAB by E is equals to, it is L2 by L1. Look at carefully, and suppose this is equation B. Okay, now comparing this A and B, that is equating this A and B. Here I am going to equate. Can you note down? Yes. Here I am going to equating this two equation. So you can see for the equation A and B, left hand side as equal. So S by S plus R, you will write here equating by A and B. Equating A and B, equation A and B. S by S plus R, S by S plus R is equals to L2 by L1. L2 by L1. Okay, we have to find the value of R. What we have to find? Yes, the value of R. So S plus R by S, we are getting reciprocal L2 if we flipped both. Now this is 1 plus R by S, 1 plus R by S equals to L1 by L2. Alright, so R by S equals to L1 by L2 minus 1, and R equals to L1 by L2 minus 1 into S. Okay, so this is the internal resistance. Here I can write, kindly draw this all the things. Here I can write the result. R is equals to L1 by L2 minus 1 into S. What is this S? Shunt resistance. Okay, S is the shunt resistance. You will get its value in ohm. So L1 by L2 minus 1 into S, that is the shunt. So this is the application, the two very important application. Okay, my dear students, now we should do some questions. Here we go with the first question. One question or two questions I will do, and then after I will give you homework. Okay, so the first question, the very simple question but very important, my dear student. The first example. All right, you're having a potentiometer. Here I'm drawing the diagram. A potentiometer a simple circuit I'm drawing. A cell, internal resistance, a galvanometer, and this is the jockey, IZ0 for IZ0. All right, and this is the balance length. This is the point of jockey. All right, yes, AB. This is the driving cell. Suppose 5 volt in question. It is, suppose it is given 5 volt. All right, now this is the very important, my dear student. When this potentiometer circuit is shunted by infinity. How much? Infinity. All right, when it is, kindly note down the question. In given figure, when potentiometer is shunted by infinity, the balance length found to be, that is the L1 or X1, you can say, balance length is found to be 400 meter. All right, 400 meter when it is shunted by infinity. Suppose galvanometer gives the reading at this point. Now this is E and this is R. Now when the same instrument, it is shunted by, the second time, when it is shunted by a resistance of 5 ohm, all right, 5 ohm, then the balance length becomes 300 meter. Okay, 300 meter. Now the question, you have to find internal resistance of this cell. You have to find internal resistance of this cell. If you can solve this question, pause the video and try to solve. Okay, now let me solve. So my dear student, what is the formula for internal resistance? It is L1 by L2 minus 1 into shunt. Now it is very important to find the value of L1, L2. Okay, just don't write the values as you find in the question. Try to use your IQ. First, it was shunted by infinity. What does it mean? If infinity will connect over here, current will be 0. It means the circuit will be considered the open circuit, and the L1 in experiment, L1 in this formula, try to remember this was the length when the circuit was open. It means L1 is given 400 meter. All right. Now when it is shunted by 5 ohm, then the balance length is 300 meter. What does it mean? When this 5 ohm is connected, this behaves like a shunt, that is the low resistance, and balance length is 300. It means the balance length L2 is given. Now it's very easy. The value of S is given 5 ohm. Now could you solve? Yes, you can solve. Put the values and try to solve. Now the next question I'm giving you. I hope you can solve, my dear students. So kindly note down and try to solve. Okay, yes. Now the next question, the second one. This is also the example. All right, I'm giving you homework. It would be better. The first one. All right, this is the potentiometer. Jockey, the galvanometer, R, and this is E. All right. Now the question, it is 2 volt. Now the question, when this circuit is connected with this cell, the balance length is, suppose it is 80 centimeter. All right, it is 80 centimeter. Now, when a very low resistance is connected here, balance length is being changed, and then balance length is found to be 60 meter. When this resistance, suppose here the resistance we have connected, this resistance is suppose, okay, 10 ohm. Okay, then the question, what will be the internal resistance? Now the second homework, the homework 2 I'm giving you. All right, this is the potentiometer. Here the 2 shell I'm connecting. You must see clearly. This is the galvanometer connected. Now this is E1 and E2. Here balance length found to be X1. All right, when these 2 cells are connected, balance length is X1, and when I flipped one cell, okay, E2, this is E2 and this is E1. When I flipped this E2, network will change, remember. Now I disconnect this one and connect with this one. When I flipped and connect with this one, this is E1 and E2. The same, when I flip this one, now circuit becomes, the balance length is X2. Okay, all right, yes, and X1, X2 are given. X1, it is suppose X1 is 250, yes, 250 meter, 250 centimeter or whatever meter. Okay, and X2 is 400 centimeter. All right, then you have to find the value of E1 and E2. You have to find the value of E1 and E2. I hope you understand. Remember one condition, E1 is greater than E2. Again, I'm explaining this question. This is a potentiometer of 10 volt battery is connected. Here in the circuit, 2 cells are in series, but the negative terminal and then for positive, then here negative and positive are connected. You find the balance length 250 centimeter, but when one cell is flipped, the balance length becomes shifted to 400 centimeter. What will be the value of E1 and E2? And the last homework, this is the very important potentiometer with the resistance (2 volt) R ohm. Okay, resistance of this wire is suppose 15 ohm and 1 meter. Length AB is 1 meter. Okay, 1 meter length. Now a battery I'm connecting here. Suppose the galvanometer, the balance point, suppose this E. Okay, for this value of E as 75 millivolt, the balance length from here, that is the X, it is suppose 30 centimeter. Okay, you have to find the value of R. This is the condition. You have to find the value of R. If 2 volt battery, that is the external source, here the 75 millivolt, galvanometer gives the IZ as 0, what will be the value of resistance. Okay, so this is all about the today lecture, my dear students. Thank you very much.